Okay, so today we will see custom partitioner and the concept of secondary sorting as well. Okay, so I mean to say, so as I have told in the last class, that uh, we are going to modify or we are going to change all the faces of the map reduce. And what are the various faces? Actually, it's a mapper face, then you have partitioner, then you have a sorting, then sorting which happens both at the mapper and the reducer side, grouping which happens at the reducer side, right? So we are going to change it each and everything. So remember that the moment you uh, write your own custom key like we did in the last class, you have to think about the partitioner, because the partitioner, as you know, it works on the hash code of the key, right? So you have a partitioner, the default partitioner. What is the default partitioner name? So the default partitioner name is the default partitioner. How does it work? The default partitioner is also known as a hash partitioner, and as the name suggests, as the name says, it's a hash partitioner, which basically means it takes the hash code of your key and does the modulo operator by the number of reducer you have set. That's how it works. Okay, so it might not work in all the cases. Your default partitioner might not give you the exact result, but remember that as soon as you make your custom key, then you have to think, then you have to see whether your partitioner has to be changed or not. Okay. So what we will do, the real problem which we'll solve it later, but for the time being we will solve a very small problem with respect to the custom partitioner. Okay, so the custom partitioner, if you see here, I've just taken a small example to emphasize of just a normal thing. I mean to say, just a very small bare minimum example to make you understand regarding partitioner. Now, to recap, we understand that for better load balancing of the key value pair, we should consider more than one reducer. And I hope you know what is the problem with the one reducer. So if you are going to use one reducer, what is the problem? The problem is all the key value pairs, will go to single machine, which might happen that your everything will be slow because copying will be slower, sorting will be slower, and everything will be slower, which basically impact the performance. Now, the second important aspect is that the problem with the single reducer is uh, it might happen that the size of the key value pairs which are getting copied to your reducer machine, it exceeds the hard disk capacity of your reducer machine, right? In other words, it might exceed the mapreduce.temp.dir, where actually your mapreduce, where actually in the data node machine you allocate some space for the temporary output. Okay, so it exceeds that particular capacity. So in that case, I have taken the very hard case. You can increase your temporary directory size, but then you can increase as far as it's your, I mean to say, you can increase maximum up to your hard disk capacity, right? So I've just taken the hard disk capacity to emphasize the fact that you cannot increase your hard disk, you cannot go beyond your hard disk capacity of your machine. So size of the key value pairs has exceed the hard disk capacity of your machine, and in this case you might want to load balance your key value pair by running more than one reducer. And that's where you have the partitioner concept comes up, and it decides which key value pair should go to which reducer. As I've just explained you, that it determines the default partitioner, which is known as a hash partitioner. It actually takes your hash code of the key and determines which, and modulo by number of reducers, and whatever the value it comes, based on that it determines which reducer it has to go. So that's how I have already given. We have already seen the partitioner, default partitioner details. Right now, for example, you have used your custom key, and the last class I have given you some assignment regarding that, right? So in that case, in that assignment, I asked you to create a custom key which represents, which has a two member variables, first name and the last name. Okay, like this, first name and the last name. So it's a custom key, and your problem statement is that your if all the names or all these names having the same last name should go to the same reducer. If you see, this is your last name and these are your first names. So the problem statement is, all the records or all the employees having the same last name should go to the same reducer or should go to the single reducer. That's what you want to do. But before you want to do that, can you think that if you use your custom key, if you use your default partitioner, then it might not work until unless you change your hash code, right? So you can have your hash code in such a way that it only gives the hash code of your first name, right? That's perfectly fine. It will work without custom partition also, but I'm just saying that you actually will, whenever you want to have the hash code, you will get the hash code for both the member variables. So just hold on for a moment. What I am trying to explain is this: the same problem I can solve it without custom partitioner by changing the hash code. So what I'm trying to just say is, so I will have a person which will okay, writable, not writable. I would like to have a writable comparable and say finish. Okay, so as I've just told you that if I go back to my slides, I wanted to, if you work with the default partitioner, it might not work because the hash codes of Smith John might be different for Smith Jacob or Smith Bob or Smith Doug. So you cannot achieve this scenario wherein you wanted to have the same last name should be possible a single user. But so in that case, you will actually write a custom partitioner in such a way that it partitions based on the last name. That's what we'll do. But if you still, if in for this same for this particular problem, if you want to actually solve it without a custom partition, then you have to generate your hash code in such a way that it takes care of only these, what do you say, only the last name. So this problem, if I want to solve it before, so private, let's say private text first name, or okay, last name, private text first name, and I will do, right click source, so generates hash code. See this hash code, I will take both the last names and the first names. So if I generally will take it right like this. So if you work like this, so and if this hash code is basically works on both first name and the last name. So this problem statement with the default hash partitioner will not work, since it will take the full key. Full key in the sense it will take the hash code of the full key, and this is the hash code which it will take, whatever the value it will take. This is the hash code which will come. So it will take the full key to determine which reset will go. So records having different first names. So if you see that here, records having different first name can go to different reducer. And the reason I'm saying Smith John is a different than Smith Jacob. So in this case, if you want to solve the problem, you have to write a custom partitioner. But what I'm trying to say, if you don't want to write a custom partitioner, you will just say source hash code and you generate the hash code, I will just take the last name. So now if this guy take, if the default partitioner now if it takes the hash code, it will take the hash code of the last name and then my problem can be solved, right? But generally that is not the way to solve these problems. So you will take the hash codes of the all the member variables. Now if you want to write your own custom partitioner, then what you need to do, you have to actually, oh, I have not given this implementation here. So I think these are my older slides which have not been updated. But then how to write a custom partitioner, I will just, so let's say this is a key. I'm not going to write your full I'm not going to write a full example here. I'm just going to give you the introduction that how this custom partition can be implemented. So let me write the source generate hash code equals, you might want to have a setter and getter methods for everything. Let me public person. Okay, so that's my, so I can have my setters and the getters method public void set first name, and this can take it up a string first name, and then you say this dot first name dot set first name. Similarly, you want also might want to write set your last name. I'm just writing it for the sake of completion. String last name, this dot last name dot set. Okay, and we already know what is the, these are our deserialization and serialization methods, right? So how do you want to write it? That's what it is saying. So I will first write the, and I have told you that write and read method in the last class when I was talking about the custom keys. The order in which you read and write does matters, because that's where you will serialize, and that's how you will serialize. The way you serialize your member variables, the same way you should deserialize it back, and that's where you have a write and the read method which serves the same purpose. But this dot, I'm first sending this dot last name dot write, and then I will be sending this dot first name dot write. Okay, once, so this is how you serialize, that's all right, and you can also deserialize it back in the same fashion, the same order. This dot last name dot read fields, this dot first name dot read fields. Okay, and how you want to compare it, for the time being I will do the comparison. Like if, for example, what I would like to compare, how would you like to compare? So this is basically how we would like to compare. So what I'm going to do, integer cmp equal to this dot last name dot compare to o dot last name. So what I'm saying, first compare the last names. If last names are same, then compare their first names. This is just an example to how do I want to compare. If the last names are same, I want to compare their first names. So I will say, how do I say if the last names are same? Else send the same, if the last names are same, then compare the first name and send the comparison value back, else else send else send as is, else send the comparison value, else send the previous comparison value as is. So if CMP is what I'm going to do, if CMP equal to 0, that's basically if so. What will happen if they are same? That the comparison will be this. Then the comparison value will be the same, equal to 0. And then if they are same, then I'm going to compare these dot first name dot compare to o dot first name, and then return the comparison value. So this comparison value, the CMP value, just wanted to explain, when you compare, the CMP can take three values. That's 0. Okay, I'll take -1, 0, and 1. -1 means this is less than other. So O is nothing but your other, right? This O, I will replace it as a other. So that's clear. Refactor, I can rename to other person object. So this object is less than the other object. Is less than the other object, and both of them belongs to, and both of them are basically person. Then I0 means basically this object is same as the other object, and 1 is means that this object is greater than the other object. So that's the significance of your CMP value. Okay, so what does it means? For example, my last name and first name. So for example, I'm just taking Smith John and Smith Jacob, and everybody understand that this comparative method will be called during sorting, and sorting happens both at the mapper and the reducer phase. Correct. Now, for example, I'll take an example of a Smith John and the Smith Jacob, both of them example. Smith John, John, and Smith Jacob. So what will happen? How they will be placed? So first and the foremost, it will compare their last names. So Smith will be compared to Smith, that will be equal to 0. Then John will be compared with the Jacob. So I'm saying this is my Smith John, and other is your Smith Jacob. And if you see this integer CMP, so this dot last name, the last name is same here. Yeah. So Smith is equal to Smith. That's fine. Now the control will go inside this because both are same. Now John and the Jacob. So in the John and the Jacob, John is greater than Jacob. How do I know that? John is greater than Jacob because JJ are same, then but O and A. So A comes before O. So this is a greater. John is greater than Jacob. So how these keys will be arranged? So it's a lexicographic sorting. So Smith Jacob, it's an ascending order, right? Smith, remember, it's an ascending order. So Smith Jacob will come first, and then the Smith John will come second. So this is how the sorting will happen between these two guys. So when you see in the output, the Smith Jacob will appear first, and then Smith John. So this is the significance of having this. So I've just explained you that this is my actually person class, which has a first name and the last name. Now, what I was trying to say that what I was trying to explain, that whenever you have a custom key like this, and you wanted to make sure that the partitioner is working properly, so you should not rely on the default partitioner because it takes the hash code of the entire key. And now my problem statement is, I want to send the same the persons or the employees having the same last name to the same reducer. and we know that this decision can be made by only by the partitioner class. So what we will do, we'll write our own person partitioner class, which extends from partitioner class. This is the class which I'm going to extend from, and say finish. And to understand that what is this key and the value, the generics. So partitioner receives a key and a value. What is this key? This key will be the input key. But what input key we are talking about? Who is the input to our partitioner? Is the mapper output. And the mapper output is nothing but our person class. Assuming that you are emitting from the mapper output key of type person, and let it be string. And this is the method which will be called get partition key value integer num partitions is nothing but number of reducer. And the number of reducer, you generally set it, you know it, either from the job class, that's your driver code. From the driver code you can set it through set num reducer, and you can give some value integer. Either from the what do you say, from when you submit the job, either you can provide as a mapreduce.num.reduce.tasks. I forgot mapreduce.reduce.tasks. I'm very sorry, let me just figure it out. Let me just see that what is that name, what is the property name. mapreduce.job.reduce. That's basically your, well, you can give some value, or either in the XML file you can specify. I can very well say integer num reducer here. Now what I want to do here is to partition based on my last name. So do I have my setters and getters? Okay, I can create one. I can actually say like this, I can select both. I can select one of them, go to source, getters and setters. Yeah, so I have created my setters and getters, but I have created a very wrong place. So let me just provide properly. Source, right click, source, generate getters and setters. Where you want to do that, I will last. Yeah. Now here's are my setters and getters. Okay. So I wanted to partition based on my last name. So I will simply do key dot get last name dot hash code. I will take the hash code modulo by num reducer. I can just do this command X. I can return the value of this. That's it, right? This is as simple as that. You are partitioning based on the last name. You are actually taking the you are not taking the hash code of the entire key, but you are just taking the hash code of your last name, and then you are modulo by number of reducer. What generally happens is the hash codes can be negative. So you do the AND operation by integer dot max value. So this AND operation, this bitwise AND, this is not a logical AND operation, guys. Thus, I have just putting one AND, which is your bitwise AND, not logical AND. Logical AND is given by two ANDs, two ampersands. Now what I'm trying to do, why this AND operation is required, why this bitwise operation? So the bitwise operation with the maximum value of integer is required to convert is required because few of the hash codes can be negative. So to convert the negative hash codes to positive hash codes, you need this bitwise AND operation. Yeah. So this is what by doing this, um, you will make sure by doing this, we will make sure that keys having the same last name will go to the same reads. Okay, so that's basically about the partitioner, custom partitioner. Now we'll talk about the actual class, actual thing. What we are going to talk about is the secondary sorting, the concept of the secondary sorting. But before the secondary sorting, the problem statement is, let's say, what is, we'll say what is, okay, this one. First, we'll define the problem statement. Okay. The problem statement is a very simple problem statement that we are going to work with employee data which I have shared in the last class, employee data. Okay, so the first columns are last name and the first name. So the problem statement is we are going to work with employee data and we are going to produce an out. So what we need to do, we need to produce an output in such a way that all the employees having the same last name are together, and when you are writing their first names, the first name should be in the sorted order. So for example, I have output. For example, I have an input. Few inputs like Sharma A, Mishra B, Mishra A, Sharma X, Mishra B, Sharma Y. Okay, something like the Sharma B, Mishra A. No, not Mishra A, Mishra D, Mishra C. So the first column is my last name, the second column is my first name. So if this is my input, the output, what I'm saying, and that when you have to write a MapReduce job in such a way that all the records having the same last name should be together, and when you're writing the first name, it should be in sorted order. Okay. So if you see M comes before S, so you know that it does a lexicographic sorting, right? MapReduce job. So all the outputs will come first. Mishra, and all the Mishras will be first. So Mishra, first what will happen? A, then Mishra B will be there because the first name has to be sorted. Then Mishra C will be there. Mishra C, Mishra D, and then you have a Sharma, Sharma A, Sharma B, Sharma X. So if you see that the output is such a way that your first names, your last names are together and the first names are sorted in nature. So this is what the problem statement is. Okay. Now, how do you want to solve it? So as I've told you, whatever the problem statement, you have to start with your output key value from your mapper. And if I see output key value of mapper, and if you see the output, the first intuition that comes to your mind, the first logic is that comes to your mind is that output key will be your last name, and the output value from your mapper would be your first name. That's the first thing. Now what you need to do, you need to quickly draw a diagram, right? I cannot tie the diagram, but what will you do? Let's say I will do something like this: mapper 1 output. So the mapper 1 output, if you see, if your key value pairs, right? So key value pairs, um, so this is the first thing. So you will have last name and the first name. So you will say Sharma, and A is your key value pair. Let's say I'm taking only one key value, Sharma, comma B from one of the mapper, from another mapper you have the output as Sharma, let's say Z. I'm just taking, and the output of both of them will go to a reducer. Let's say, assuming you have a single reducer right now, single reducer. Now if it is single reducer, you will have all the keys, right? You understand that our key value pair, sorting happens only on what? Keys, not on values. So you will say sorting happens, and this is a very important point which you need to understand, that sorting happens only on keys, never on values. And the ordering might vary. Ordering of the values might vary sometimes. So the output of the grouping operation, if you see the output of the grouping operation, if from here it could be something like this, Sharma. Sometimes A can come first, sometimes Z comes. So this could be one. Sometimes it could be ABZ, ABZ, sometimes BAZ. So this ordering can vary. So you cannot rely on the ordering of these values. But one might want to contradict this fact that, okay, that's not a problem, that my values are not sorted. One might want to take a chance like this. They might want to collect in the reducer. So since the ordering of the values, this ordering of the values is not guaranteed to be in a sorted order, in sorted order. So what you might want to do, is this: is you iterate of the list of the values over the values, put them in an array, in list or array, and then sort it, right? You might want to do this, but you need to think, you need to give a thought. If there are a million values, you cannot put them in an array. So the problem will not, you cannot solve this problem if you want to do that. Then what is the first step? What you want to do? Since what we are talking about here is, we wanted this first name should be sorted, or in other words, these first names are nothing but are my values. And what we are talking about, sorting the values. But remember, sorting happens only on keys, never on values. So how do we do that? The first step, the concept of sorting the value is known as secondary sorting. But the first step, how does it goes? So it's just a concept, but there are a couple of steps which you need to do. Concept of sorting the values is known as secondary sorting in MapReduce job. in MapReduce. And the first step, what you need to do, first step, you need to make the value as a part of your key. So you make the value as part of your key. And what I'm trying to say, what is value in our case is first name is my value, and the last name is my key in my current output, right? So you need to make the value as part of your key. It's nothing but we are going to form the composite key, right? So this is basically a composite key. It's nothing but combination of your first name and the last name. This is what I was telling you. Correct? Okay. So what you need to do, so here you have a person class, and this is what you need to do. You wanted to, so I was actually, I wanted to go take this problem. So I wanted to understand, you wanted to write this class to make you understand that this will be used in our secondary sorting concept. So the secondary sorting concept starts with here. And the implications or the applications of our secondary sorting we'll see in a couple of MapReduce jobs later. So we are going to work with the, so now the first thing, so we are come up here, and the first step which we need to do is this custom key which we are going to form. And I've just explained that custom key, and as soon as you write a custom key, you know that you have to think about the partitioner. And yes, the problem statement says that you need to make sure that um, the all the last names are kept together, which means if all the last names are kept together, if all the last names needs to be, if the same last names needs to be together, then they have to be sent to the same reducer. And who does the job of sending the key to the reducer? It's a partitioner. So you have to write your own partitioner in such a way that the key is having the same last name, goes to the same reducer. And this is what we have written, that we are going to have our this person partitioner, which makes sure that the key is having the same last name goes to the same reducer. Now what happens at the mapper side? It's an Now once you do that activity, okay, now our mapper is outputting. Our mapper is now outputting custom key. I will take the custom key if I say person, and the value would be the first name, because ultimately this is the guy who has to be sorted, right? First name is my value, and the person is a combination of my first and the last name. That's what I have just shown you. So the mapper is now going to emit this key value pair. My key is person class, and the value is a first name. Okay, so let us give some output. Mapper 1. The mapper 1 is emitting. So what I will say, I will take the same example, Sharma X and everything. Sharma colon X comma X. This Sharma colon X is nothing but my person class, and this is my first name X. Sharma, I'll say Mishra, another key value pair, Mishra colon B comma B. Here Sharma colon A comma A. I can have another mapper. Mapper 2, which is emitting Sharma colon B comma B, and here we have Mishra comma S. These are my key value pairs which are emitted from the mapper. So partitioner will make sure that all the Sharmas go to the same reducer, all the Mishras will go to the same reducer. But what happens at the mapper? We have a sorting also, right? And we have to do the sorting. Now at the mapper and at the reducer, sorting happens. Now what we need to do is that when Sharma and Mishra are compared together, you need to make sure that the Mishra come first, because M comes before S, lexicographic sorting. Okay, but when Sharma X, and remember sorting happens on key, so I'm talking about this part only. So Sharma X and Mishra B, when it is there, so what I need to do is when they have the different last names, then I want to compare their last names only. But if I'm going to compare Sharma X and Sharma A, since last names are same, I want to compare their first name so that this A can come up X, right? So that's what we need to do. So what we need to do, if first check how we need to do the sorting. Sorting should be done in such a way. So sorting logic would be that first compare their last names and then compare, and if they are same, then compare their what? Then compare their first names. Correct. Now, if with that logic, if I'm gonna do that, so Sharma and Mishra, so Mishra will be coming first. Then, right, because Sharma and X, Sharma, whatever keys compared. So, if you're comparing everything, so when you compare Mishra and Sharma, since M comes before S, Mishra will come up automatically. Now, when these two keys are getting compared, Sharma are same, but then A is smaller than X, so Sharma A should come next, and then you have a Sharma X should come next for this mapper. Similarly, for this mapper, you have Mishra A should come first, and then Sharma B should come next. Right. So this is how the output of the mappers will look like after the sorting logic. And now this is the logic which we have written, is which we have already written. I've just explained you that. So you are going to first compare the last names. If the comparison is same, that is 0 0, then you're going to compare their first names and then return the comparison value. It could be anything, but since our problem statement, whatever we have stated the problem, this logic actually fits there. So we actually have done the sorting. Correct. Now what will happen? So this is your mapper output. Correct. This is my mapper output 1, and then you have, this is a mapper output 2. Correct. And now output of the mapper, so this is a sorting is done. Now we know that output of the mapper will go to the reducer. Let's assume you are running to reducer. Since I wanted to explain that you have 2 keys, so they might go to a different reducer. So you have a reducer 1, and here you have a reducer 2 machine. So all the Sharmas will go to one reducer. So let's say Sharma B comes first, then you have a Sharma A, and then you have a Sharma X. This partitioner will make sure that all the Mishras go to the same reducer. Okay, after that again the sorting will happen and the same logic will be working. Same sorting. So after the same sorting, what will happen? Only thing, that is rearrangement of your key value pairs. So Sharma A will come top because that is where you have the logic, right? So Sharma A will come top. So you have a reducer 1. So Sharma A will come. Then Sharma B. And then Sharma X. Okay. Then reducer 2. Okay. In this you have a Mishra A. And then you have a Mishra B. Because that is the logic which you have written. Because when the last names are same, then you have a if the last names are same, then you will compare your first names. So it will be now sorted. After the sorting, you have the grouping operation, right? Your favorite operation. But remember that grouping operation, what does the grouping operation means? Grouping all the same keys are grouped together. Are grouped together. But if you see, none of the keys are same here. So the output of the grouping operation will be something like this. With this, auto grouping operation will be like this. It will be same as your sorting operation because the keys are not same, and the grouping operation says that all the keys having the same, so all the same keys will be grouped together. You don't want the output like this, because here in this case, the reducer in this reducer 1 you have a 3 keys. Reducer will be called 3 times. In the reducer 2 you have a 2 keys, so it will be 2 keys. It will be called twice. Your reducer function, your reduce function. You don't want the keys like this. What you want, the keys like this. You wanted the key something like this. Sharma and A, comma B, comma C. A, comma B. What you wanted, all the values should be grouped together. What you want here, what I'm done here, all the values are grouped together to the same last name. And this cannot be, and this cannot be achieved with a default grouping comparator. Because this default grouping comparator works with entire key, and entire key we don't have the same key anywhere. So what we need to do, we have to write our custom grouping comparator now. Custom grouping comparator which will be grouping on the last name. That's it. That's what we need to do it. And let us see how to write our own custom grouping comparator.
Sorry for the interruption. In place of C, it will be X.
Yeah, I'm giving the name as a person comparator. Implements writable comparator. Okay, this is not implements, then it should be extends writable comparator, right? So this is the class which you're going to extend writable comparator. Okay, and we will source generate. So what we do, override implement methods. We gonna override this method writable comparable to writable comparable, and actually it should take it up the uh, comparator. The reason is it should take it up the class which it is actually going to compare. Yeah, raw compare public interface raw comparator T writable comparator should be just 1 minute. I wanted to see where is the constructor of this class. Okay, create instances. Okay, so what we will do, we will key class, and also it should take it up writable comparator key class. So what I'm going to do, I will say that you take my person key class as my, okay, it's not taking it up, then it's okay. What I'm going to do now, public person comparator, where is this key class configuration, person dot class. I will say true. Okay, it will go, it will work. Okay, so create instances, key class, then yeah, this dot conf new configuration, that's fine. So this is what I want, that it's actually we have to create this constructor. This is has some problem. If you don't give the constructor, there was some problem. That's fine. So now what I want to do here is I want to compare them. So this is the actual method which will do the grouping operation for you. So this method, so this, for to give you just an overview, this writable comparator can be used for both grouping comparator as well as sorting comparator. Now generally I have not shown you how to write the sorting comparator because sorting was done by the compare to method for us. But if you want to write your sorting comparator, it can also be done by the same way which we have written. Now here what we want to do is writable comparable A and writable comparable B. There are two objects, person objects. So person P1 equal to A, person P2 equal to B. I'll cast it. Now what you want to do is you wanted to do the grouping operation. Only you want to group only on the last name, right? So what you do here, return P1 dot compare to P2 dot P2 sorry, very sorry, not this, P1 dot get last name dot compare to P2 dot get last name, and that's it. You have done your grouping comparator. Now once you have written your grouping comparator the way which you have just done now, then the output of the reducer will look like this. It will not exactly look like this. It will take the smallest key. So what is the smallest key here in all of the thing? The A1, right? So it will take the smallest key and make that as your key, and the list of values will be ABX. Now Mishra colon A, and it will be the smallest key that will be made as your key and a list of values. Now in the reduce method, you don't have to do anything. So in the reduce method, so if this is the output of grouping operation, in the reduce method, when you iterate over the values, you will get the values in sorted order because you will get the values in sorted order because they are already sorted right here. So when you iterate, you will get the values in sorted order, and that's how you do that secondary sorting. Okay, but we have not written the person mapper, person reducer, person mapper, person reducer, person driver class. So to make this complete secondary sorting, which we'll do it in the next class, that how to, the only part which is written, only part which is pending is person mapper, person reducer, or the person driver. Let us complete that part as well so that we can run tomorrow, right? So let me write the person mapper, extends mapper. I'm gonna use my which input format, text input format. So it will be long writable, it will be text, it will be, then it will be person, and the value will be the text. Private person equal to new person, private text, first, not the first name, in new text, and then you right click, source, override implement methods. You will implement your map method. Okay, then assuming it's a CSV file which is coming up. In the last class I was taking the CSV file, so let's say it's a CSV file. So so it's a delimited by comma. So string array splits equal to value dot toString dot split, comma as a delimiter, and then you take your string last name. Okay, if splits dot length greater than 2, then you will take string, let's say last name equal to splits of 0, and string first name equal to splits of 1. Then you say output key dot set last name, set last name is your last name, then output key dot set first name is your first name, and your first name dot set first name. So you have set your output key and the output value, and then you say context dot write person key, that's your output key, and the value first name. That's it, you have written your mapper class. What happened here? Okay, so you have this is your mapper class. Now partitioner will work, comparator will work. Okay, let me write this class as a grouping comparator, person grouping comparator. Now let us write our person reducer class. extends reducer. It would be person text. I wanted to output the text itself, let's say text. I'm just saying text. Okay, and source override implement methods, reduce method we will override. And so as I've told you that output of the grouping operation, these values will be always be in the sorted order, right? So this will be in the sorted order. Now you don't have to do that, you just need to iterate. For text, first name colon values, so you just need to say context dot write. So context dot write your key dot get last name, and the value will be the first name, and now output will be coming as is, so you don't have to do anything. Now it's done. So this will be the reducer class code. And the last bit, you have to write your person driver class. Extends configuration, extends configured, implements tool. And you have to, okay, and you have public static void main string array of args, and you just need to say toolrunner dot run new person driver, and you send the args to that guy. Okay, so what you need to do here, job, you need to create a job object, right? And job, I'm very sorry, job equal job new, not the new, you need to say job dot get instance and get conf. Once you do that, you have the job object. You need to set job dot set jar by class, that's your person driver class. And then you just set job dot set input format. If you don't set it, it will take the default input format. We'll set mapper class. Set mapper class, it's your person mapper. Then you will set your reducer class, job dot set reducer class, it's your person driver dot class. And then you need to set your, I'm very sorry, person reducer class. Then you need to set your map output key class, job dot set map output, a map output key class. Map output key class is a person dot class, and the job dot set map output value class is your text dot class. Text dot class, right? So now you have to set your output of your reducer output key value pair for reducer class. Job dot set output key class, set output key class, that's your text dot class. Job dot set output value class would be text dot class. Once done, you need to also set job dot set grouping comparator, and that's your person grouping comparator class, because you have used that person grouping comparator dot class. I have not set anywhere which is my partitioner class. I need to say job dot set partitioner class. I have done a person partitioner class, right? We have written person partitioner dot class. Okay, and then you have to specify input data and output data. File input format, dot add input path new path of arcs of the first will be the 0. The first will be our input, and then we have a file output format where we want to store our uh, where we have input data, and file output format we have to specify where we want to uh, put our results into. New path of arcs of 1. Once done, that's it, and then you need to finally say job dot wait for completion and true, and that completes your secondary sorting. You have to it's a very simple concept, but then how to use it, because I have just given a very simple thing, that where you have to start with custom key, then you have to think whether custom partitioner works, then you have to see whether your sorting is going to give the appropriate result or not, then finally grouping. So this is actually, we have written the entire thing. So the two direct applications of the secondary sorting will be reduce side join and the TF-IDF, term frequency inverse document frequency problem. Okay, so tomorrow what we'll do in the next class, or tomorrow, most will day after tomorrow, we will run this secondary sorting and see whether it's gonna give us the correct results or not. So thanks guys, thanks for today. Let's meet in the next class.